Number 12. When magnesium carbonate, solid, is strongly heated, it produces solid magnesium oxide as gaseous carbon dioxide is driven off. And so when we heat this substance here, our two products are MgO and CO2. A asks, what is the percentage loss in mass as this reaction occurs? So as CO2 is driven off and goes away, what's the percent loss every time one molecule of this is turned into this? So first off, we need to calculate the mass of magnesium carbonate, right? 1 magnesium, 1 carbon, 3 oxygens, multiply the number of atoms by their respective molar masses, add them up. So here's my mass due to magnesium carbonate. Then magnesium oxide, or you can do this by calculating the mass of carbon dioxide, which would be 44, right? But we have 1 magnesium, 1 oxygen, here are their masses, multiply them, add them together, we get 40.31. I'm going to take my 40.31, divide by the mass of the overall molecule, which is 84.32, multiply by 100, we get 47.8%. So, compared to the original sample, the magnesium carbonate, when we have MgO that remains, that's 47.8% of the original sample. 47.8% of the original sample remains. But we're not being asked how much remains, we're being asked how much is lost as this CO2 is driven off. And so we simply subtract how much remains from 100% to get 52.2% lost. You could also, if you wanted to, you could also calculate the mass of CO2, because since the CO2 is the thing that's being driven off, if you simply replace the mass of magnesium oxide with the mass of carbon dioxide, which would be 44, multiply that by 100%, you also generate 52.2. So 2 different ways of doing part A, both are correct. B asks us to assign the oxidation number to each atom in magnesium carbonate. Well, we know that oxygen is going to come in with a -2 because it's almost -2. There are 3 of them, so that's a total of -6. Magnesium is a main group 2 element, so it's going to have an oxidation state of +2. So we have a total of +2, a -6. In order to get both of these values to even out, balance out, have an overall of 0, carbon is going to have to be a +4. So we have magnesium with a +2, carbon with a +4, and oxygen with that -2. And we'll finish up with part C. Does the oxidation number of carbon change upon the formation of CO2? So when we actually go from the original sample, magnesium carbonate, and turn the carbon into carbon dioxide, is the oxidation number changing? Well, let's figure out what it is in carbon dioxide and we'll compare the two values. Here's oxygen with the -2. There are 2 of them, so that's a total of -4. That -4 needs to be balanced out by this single carbon, so this single carbon must be a +4. +4 here in magnesium carbonate, +4 in carbon dioxide, so no, there is no change upon the formation of carbon dioxide.